Okay, today we're going to be looking at some cool, and by today I mean really, whenever you're watching this, I'm making all these videos on the same day. That's why my voice is gone. But we're going to be looking at some cool things having to do with the unit circle today. But if we're talking about the unit circle, you absolutely need to be able to fill out this unit circle like it ain't no thing. So let's think about 0 degrees and 0 radians gives us an x value of 1, a y value of 0. Again, remember that x is cosine and y is sine, and tangent is slope, because tangent is sine over cosine, y over x, so we get our slope. Okay, well, our first line there is 30 degrees, which is pi over 6, and our values are root 3 over 2 and 1/2. Next line is 45 degrees with pi over 4, and we get root 2. That's a 3. We get root 2 over 2 and root 2 over 2. Next line is 60 degrees. We get pi over 3, and it flips the 30-degree angle. So we get positive 1/2 for x and root 3 over 2 for cosine. And then finally we got 90 degrees, which is pi over 2 radians, x value 0, y value 1. It needs to be that quick. If it's not, you need to practice this a little bit more, because you can't do anything in this unit without the unit circle. But let's look at what is actually happening in the unit circle. So before we can do cooler things, we need to be able to evaluate functions. So I want to list the 6 trig functions for negative 7 pi over 6. And what I do is I draw myself a little reference unit circle, and I split each half of the unit circle up into whatever the denominator is. So in this case, 6 pieces. So if I split it in half and then each half into thirds, I get my 6 pieces, and I'm going to do the same thing in the bottom half as well. So now I have 12 equal pieces, each half has 6, and all I have to do is count. And let's go to whatever value is in that numerator, negative 7. The negative tells me to go clockwise, so I start right here and I go 1, 2, 3, 4, 5, 6, 7, and I end up right there. So think about this reference angle right here. What does that compare to? Well, that angle corresponds to this angle right there, which is pi over 6. The coordinates of pi over 6, I know, are root 3 over 2, comma 1/2. So that tells me right here that these coordinates are negative root 3 over 2, comma 1/2. So we know those values. I wrote them very small, apparently. But now we're just listing the values of the functions. So sine of theta equals the y value, which is 1/2. Cosine of theta equals the x value, which is negative root 3 over 2. And tangent of theta equals sine over cosine. That is an important identity. Remember, tangent of theta equals sine of theta over cosine of theta. So sine is 1/2, cosine is negative root 3 over 2. Simplify that, cross off those 2's, we get 1 over root 3, and it's negative. But we need to rationalize that. So multiply by root 3 over root 3, and you get negative root 3 over 3 for tangent. Okay, now we need the 3 reciprocal functions. Cosecant goes with sine, so cosecant of that theta is going to be the reciprocal of 1/2, which is 2. Flip the fraction. Reciprocal of cosine is secant of theta, and we need to, again, flip the fraction. So we get negative 2 over root 3. We need to rationalize and get negative 2 root 3 over 3. And then finally, reciprocal of tangent is cotan, and we flip the fraction. I'm going to flip this one right here, thanks Alec, because that shows me it's easier to see that I will get root 3 over negative 1, which is just negative root 3. So I have my 6 values right there, and it's just that quick. If you're doing problems in the book, you might see an answer like this, where the answer is not rationalized. But I would like you to rationalize your denominators. It's not asking too much. It should not take too much work from you to do so. So let's do the same thing with 9 pi over 2. Again, I draw a unit circle and I split each half into however many pieces the denominator is telling me. Telling me 2, so I'm going to split it like that. So now I just need to count. I start here. My angle is positive, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And it looks like an awkward flower, but the point is I end up right there where the x value is 0 and the y value is 1. So sine is going to give me 1, cosine is going to give me 0, tangent is going to be undefined because it's sine over cosine. You can't divide by 0. Okay, that's cool. Well, if the reciprocal, or I'm sorry, if sine is 1, the reciprocal of 1 is 1. So cosecant is also 1. Okay, if cosine is 0, well that's the same as 0 over 1. So this reciprocal, secant, is going to be 1 over 0, which is undefined. The reciprocal of tangent is cotangent, and that will give me 0 over 1 if I flip that fraction, which is 0. So what I want you to notice is that if you end up with a 1 as one of your trig values, the reciprocal of that is still going to be 1. It doesn't matter if it's negative, the reciprocal of negative 1 is negative 1 as well. If you end up with a 0 as a value for a trig function, the reciprocal will be undefined, and if you end up with an undefined, the reciprocal will be 0. Those are good patterns to notice. Check yourself on this one real quick, pause it and do the problem, and check your answers. Okay, check it with this one, pause it and do the problem, and here are the answers. Okay, so what we want to do with the rest of this video is we want to be specific about the symmetry that we've noticed in the unit circle, and we're going to look at a couple trig puzzles. So, look at this. We have some generically labeled unit circle. We have that green angle, which is just some positive theta value, and then we have that turquoise angle, which is the same angle but in the negative direction, so it's negative theta. And we want to think about the symmetry that we know right here. So think about this point right here. That point is going to correspond to the x value, cosine of theta, and the y value, sine of theta. And down here, we're going to get this point will be the cosine of negative theta and the sine of negative theta as well. All we're doing is using the fact that cosine is x and sine is y. But think about the symmetry. How do these 2 points compare? How does this y value compare to that y value? My dog's snoring. It's crazy cute. How do those 2 y values compare? Well, they're opposites. So I can say that the sine of negative theta is the opposite of the sine of theta. And how do these 2 x values compare? Well, they're the same. Look, they share that base of that triangle. So I can say that the cosine of negative theta equals the cosine of positive theta. Where have you seen this before? Negative sine of theta equals sine of negative theta. Cosine of theta equals cosine of negative theta? Well, what if we didn't have signs? What if we were just talking about some generic function, f of x? This would be like saying negative f of x equals f of negative x. And this would be like saying f of x equals f of negative x. Do you remember where you've seen this before? Well, this is the definition of an odd function. And this is the definition of an even function. What is an odd function? What is an even function? Well, the simplest odd function you can think of is y equals x squared. Think about what that looks like. It looks like that, more or less. And what does it say? Well, we know, say we go some positive x value over here, go up to your graph, we have some point x comma y. An even function says you can go that same distance to the left, so negative x value, and go up to your graph, and you will have the same y value. So negative x comma y. Same y value right there. That's an even function. That's all an even function says. So cosine is an even function. So we should see that symmetry when we graph it in a couple of days. Okay, well, what about sine? What's the easiest example of an odd function you can come up with? How about y equals x? Y equals x looks like that. And in a similar fashion, it says if you go x to the right in the positive direction and hit your graph, you get some y value. Go that same x in the negative direction and go down to your graph, you get the opposite of that y value. So if this is x comma y, this point right here is negative x comma negative y. And so this, what we determined from the symmetry we saw, is that sine is an odd function and cosine is an even function. So again, when we graph these in a couple days, we should see that symmetry. But these aren't the only functions we're dealing with. We also have the tangent function. Do you think tangent is odd or do you think tangent is even? Well, let's look at this algebraically. Tangent of negative theta can be rewritten using the identity sine over cosine. You just need to make sure you make the insides the same. So sine of negative theta over cosine of negative theta is tangent of negative theta. And, well, what do we know about sine of negative theta? We know that we can replace it with negative sine of theta. So we could say negative sine of theta in the numerator. And cosine of negative theta, what can we replace it with? Well, we can replace it with cosine of theta because it's even. So we get cosine of theta right there. What is sine theta over cosine theta? Well, it's tangent theta. So we get negative tangent theta. So from the left to the right, we have tan of negative theta equals negative tan of theta. Which is that, odd or even? Well, that's the definition of an odd function. So sine is odd, tangent is odd, and cosine is even. What about the reciprocals? Well, the reciprocals will follow the same pattern. So, since tangent is odd, cotangent is odd. Since sine is odd, cosecant is odd. Since cosine is even, secant is even. They stay the same. So we obviously have graphical implications with that, but we also have algebraic implications. If we have sine of negative 9 pi over 4, we could rewrite that as the negative sine of positive 9 pi over 4. If we have the cosine of negative 9 pi over 4, we could rewrite that as the cosine of 9 pi over 4. And if we had tan of negative 9 pi over 4, we could rewrite that as negative tan of positive 9 pi over 4. You can always simplify it down and pull that negative out of the inside of your function using the even and oddness of your function. Okay, last thing we're going to talk about today or what I like to call trig puzzles. You probably remember these from last year. You draw yourself a little reference triangle. Tangent of theta is 5/12. Tan is opposite over adjacent. So opposite is 5, adjacent is 12. What's the hypotenuse? Well, it's 13. That is a Pythagorean triple. That is a number you should remember. 5, 12, 13, right triangle. It's a very special triangle. Pythagoras loved them. And if you don't remember it, use the Pythagorean theorem very quickly to get 5 squared is 25 plus 12 squared is 144 is 169, and the square root of that is 13. So we have our triangle. We want to know what's the value of cosine of theta. Cosine of theta is adjacent over hypotenuse, so we get 12 over 13. But we're told it's negative. Typically, I will not tell you if it's positive or negative. I'll give you some other trig value, and you need to figure out what quadrant you're in. This is all students take calculus. So, what do we know? We know that tangent is positive because we have 5/12, which means we can't be in that quadrant, and we can't be in that quadrant. It has to be either A for all or T for tangent. But we also know that cosine is negative, so we can't be in that quadrant because cosine is positive. So we have to be down here where tangent is negative. Tangent is positive, which means cosine is negative. That was weird. Okay, let's look at another one. Sine of theta is negative 3/5. We're going to do the same thing. I'm going to ignore the negativity of that 3 or maybe of that 5. I don't know. What I'm going to say is that sine is 3/5. Sine is opposite 3 over hypotenuse 5. So what's this third length? Well, it's 4. Again, it's a Pythagorean triple. This is a 3, 4, 5 triangle. You either need to know it or you need to use Pythag quickly. To do 5 squared is 25, minus 3 squared is 12, equals 4 squared, which is 16. And I definitely just said 3 squared is 12. 3 squared is 9. 5 squared minus 9 squared is 16, which gives us that 4. Okay, but now we need to say tangent of theta. Well, tangent is opposite over adjacent, but is it positive or is it negative? We need to figure out where we are. So, what do we know? We know that sine is negative. All students take calculus. Sine is negative, so I cannot be in the top there. And cosine is negative, so I cannot be in that quadrant right there. So I have to be in this quadrant right here, where tangent is positive. So positive 3/4 is my answer. And we're done.